welcome to another amazing time with Mr. Moses. So today I'll be taking us on a switch ride into understanding the compound pendulum practical. So in this video, the title of our practical of our experiment for today is the compound pendulum. So in this video I'll be showing us the step-by-step procedures on how the compound pendulum is being carried out. So get your writing materials, sit tight, and everything concerning the compound pendulum will be exposed to us in this video. Okay guys, for this practical session I will be taking us on a switch ride concerning the title of our practical, which is the compound pendulum practical. But in this practical, our aim is to determine the radius of gyration and also the acceleration due to gravity of a compound pendulum. For this experiment, there are a set of apparatus that is needed for us to be able to carry out this experiment. I will be showing us this set of apparatus shortly. So, to carry out this experiment, we need set of apparatus for us to be able to carry out the compound pendulum experiment. So firstly, we have our wooden knife edge, which we will use to check the center of gravity of our meter rule. So we have our knife edge, our meter rule. It is just not a meter rule, it is a perforated meter rule. As you can see, it is perforated at different parts. It is perforated at 50. Okay, let me take it from this other side. It is perforated at the 5 centimeter mark. It is perforated at the 10 centimeter mark. It is perforated at 15 down to about 50 centimeter. So the next that we need for our experiment is our optical pin. So we need our optical pin for the experiment. And apart from the optical pin, we also need our retort stand and the clamp. So firstly, for this experimental setup, what we'll be doing first is to balance the meter rule on the knife edge to determine the center of gravity of the knife edge. So what I'm going to do first is to show you how to balance the meter rule on the knife edge. So I move it at the center. You can see it is still moving towards the right. It is not yet balanced. That means the weight is on the right. That is why it is falling towards my right hand side. I move it a little bit. Now it is falling towards my left hand side. I will adjust it until the meter rule is balanced on the knife edge. So right about now you can see the meter rule is balanced, and we have, from my reading, ensure you avoid error due to parallax while reading on the meter rule. For my reading, I can see that the meter rule balanced at 50.2 centimeter on the meter rule. 50.2 centimeter on the meter rule. Across different meter rule, it might be different. So it might be 49 point something, so it might cause the 50 mark. However your answer is, you must be able to give us what you see on your meter rule. So on my meter rule, what I'm having here is that the meter rule balance on the knife edge at 50.2 centimeter. 50.2 centimeter on my knife edge. So the title of my practical is the compound pendulum. Then I will record this center of gravity on the knife edge as Sg. Sg is equals to 50.2 centimeters. So the next is our experimental setup. For the experimental setup, you take your cork borer, you bore the cork, then you insert your optical pin. This is your optical pin. Then you insert your optical pin into the cork. Then after you insert your optical pin into the cork, the next thing we do is that we place this optical pin on the retort stand. You can see the meter rule is perforated at 5, at 10, at 15, at 20, down to about 50. So this is the experimental setup for the compound pendulum practical. So using our stopwatch, the first thing we are going to do after placing these are the 5 centimeter mark. We are going to oscillate the compound pendulum about this main position. So what I'm going to do is I'm going to tilt or displace the meter rule from its equilibrium position. That means from its rest position, I will displace it from its rest position. Then I will allow it to oscillate 10 times so that I can get the period for 10 oscillations. So at the 5 centimeter mark, the first one, I'm going to displace it from its equilibrium position, then allow it to oscillate. Remember, the total what we mean by one full oscillation is the movement of this front and back. We complete one oscillation. So we are going to have 10 complete oscillations, and we are going to record the time it took to complete what? 10 full oscillation. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I will record the time. Here is the time it took me to complete the first 10 oscillation. I will record this time as the first time T1. Now I will repeat the same thing again. I will reset my stopwatch. Then I will repeat the same thing again for 10 oscillations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So after that, I will take this out from the 5 centimeter mark, then I will move it to 10. So right at the 10 centimeter mark, I will repeat this same practical procedure at the 10 centimeter mark. I will displace it from equilibrium position and record the time for 10 oscillations. Eight, 9, 10. I will repeat the same practical exercise for 10. I'll repeat it for 15, for 20, for 30, for 35, for 40, and that is it for the simple pendulum practical. So I repeat again, we put it at 5 centimeter, then we take 10 oscillations. After taking 10 oscillations, we repeat the practical for 2 more times, then we move to 10. We do the same thing for 10, we do the same thing for 15, we do it for 20, we do it for 25, we do it for 30, 35, and we stop at what? At 40. So if you have been able to do this, you've been able to get 3 times, 3 different records for your time for individual recording at 5, at 10, at 15, at 20, down to what? Down to 40. So guys, it's been a wonderful time taking you through the procedure of the compound pendulum practical. But next, after this video, in my next video, I'll be showing you how to calculate to get the radius of gyration and the acceleration due to gravity g. So ensure you subscribe, like, and leave any comment behind if you are having any issue with the procedure of the practicals. Remember, please don't forget to like and subscribe so that you'll be able to get more and more videos, such as the next video on how to calculate the radius of gyration and that of the acceleration due to gravity. Bye bye. See you in the next practical session.